ahead and look at the producer surplus. So this is benefiting the producer now. So producer surplus is the difference between the total amount the consumers actually spend for something and the total amount that the producers were willing to accept. So it's the extra money that the producers are getting from the consumer. So consumers are spending more than what the producers were willing to accept for the item. So this is the difference between the total amount consumers actually spend and the total amount producers are willing to accept for X units. So if we get a visual for this one, let's go ahead and sketch our axes here. So X and price, so this will be price, this will be the number of units, and this is going to be based on the supply. So if we sketch the supply function here, that's increasing. And then the equilibrium point, so let's say that this is the equilibrium point. So this is going to be X sub E. This is going to be P sub E. The producer surplus is this area right here. So this represents the producer surplus. And if you think about what this means, well, it's an integral because it's an area. And think about what we did in the previous section. So it's the area that's bounded by this horizontal line and S of x, the supply function. So P sub E, or this horizontal line, will always be greater than S of x. So that means that you would take P sub E and you would subtract off the supply function, and then you're going to integrate from 0 to x sub E. So if you look at the formula down below here, this time for the producer surplus, it's going to be P minus S of x. So P is first because that's greater, and then S of x is below it. And then you're going to integrate from 0 to x because that's the region that you're looking at. So that's where it comes from. Let's go ahead and actually try an example where you see all of these put together. So if you go to the next page here, we have an example where we want to find both the consumers and producer surplus for a product where we know the demand function and we know the supply function. Notice it doesn't say anything about our equilibrium point. And both functions or both integrals or formulas require you to know both the x value and the p value at the equilibrium point. So that means the first thing you have to do, if you think about your formulas, is you have to find x and you have to find p for the equilibrium point. And in order to do that, that's where d of x and s of x are equal to each other. So that's what we have to do first. We have to find that equilibrium point. We need to know our bounds for integration. We need to know the p-value because both are required in our formula. So our first step for this is going to be to find the equilibrium point. So in order to do that, that's where the demand, the demand is equal to the supply. So set the two functions equal. So we have 25 minus 0.005. Let me rewrite this so it's a little bit neater. So 0.005 x squared equals 0.004 x squared. So let's go ahead and combine our like terms here. So let's group these here. So let me just bring this over first. So we end up with 25 equals 0.009 x squared. And what I want to do now is go ahead and actually just divide by that 0.009 so that I can get x squared by itself. So let's divide both sides by that. And then we can take a look and see if we could factor it. Or since it's just an x squared, this should just say x. This should just have the number, not the x squared. So since it's just going to be an x squared equal to a number, I can just use the square root method, because if you look at what we have here, this fraction, you're not going to want to try to factor that. So what I'm going to do is just say that this is 25 over 0.009 equals x squared, and then just square root both sides. And then that way we can just type that in our calculator. And you're going to end up getting a rounded value, which is fine. It just means that we're going to have a rounded x and we're going to have a rounded p when we go to solve this. So this is going to be x equals plus or minus, you get 52.7046, something like that. Again, we're going to reject the negative here. So that means I'm going to say that x sub e is approximately equal to 52.7. I'm just going to round that one decimal place because I don't want to use this entire long decimal as my x value in my bound. So now that I know what x is, now that I solve for x when the two functions are equal, well, I still don't know what p is. So p is actually easy to find, because if this is the x value that makes these equal, well, plug that into one of those functions to find p. So in order to find the p value, you're just going to plug into either function. So plug x sub e into either d of x or s of x. It doesn't matter which one. So pick one that's easier. So I'm going to pick the supply function. It looks a little bit easier. So if I plug into s of x, that was just this, the 0.004 x squared. So plug in 52.7. So 0.004 times 52.7 squared. And again, this is going to give me an approximate. So 11.11 is my approximate for that. So then that tells me, so if this is P, this tells me the equilibrium point is 52.7, 11.11. So sometimes you'll have questions where it'll just ask you to find the equilibrium point. So that's what you would be doing. You would be stopping there. You'd say, okay, there's my equilibrium point. But for this question, it wants us to go further, and it wants us to find each of the surpluses. So the next step here, now that I found my equilibrium point, well, and I know my x value, I know enough information to be able to just plug in and integrate both and come up with values. So for step 2 here, I'm going to just do the consumer surplus. Not that it matters, you just pick one. So the consumer surplus, remember, is the integral from 0 to x of the demand function minus p sub e. So then we plug in. So 0 to 52.7. The demand function from the top of the page here is this 25 minus 0.005 x squared. So 25 minus 0.005 x squared minus p sub e, which is the 11.11. So then we want to combine our like terms here before we actually integrate. So 25 minus 11.11 gives me 13.89 minus 0.005x squared. And now I integrate. So we get 13.89x minus 0.005x to the third, divide by that new exponent, keep your bounds at the end. And now we plug in. So 13.89 times 52.7 minus 0.05 times 52.7 to the third over 3. You could simplify that a little, like do the 0.005 divided by 3 first if you wanted. Not that it's going to make it any easier. And then I plug in the 0 now. Which oftentimes, remember I said that this is going to go to 0. So if you recognize that as when I plug in 0 here, this whole thing's just going to become 0. You don't even really have to show the substitution. You could just say minus 0. Just don't forget about it though, because sometimes when there's e's involved and there's exponents, those zeros aren't going to go away. So just be aware of that. So then when I actually go ahead and subtract these, and I multiply by the 52.7, plug in, subtract, I end up with $488.06. And again, this is an approximate because I rounded, but that's really what we're looking for. So that's a consumer surplus. So that's the additional amount of money that consumers were willing to spend but didn't have to spend. And then if we look at the producer surplus, so that's the next one here, and the last part. And remember, you could have done steps 2 and 3 in any order. It doesn't have to be like this. Once you know your equilibrium point, it's basically just integrating. It's just plug into these formulas and integrate. There's nothing special about it other than you have to find the equilibrium point. So then we have our producer surplus formula. So from 0 to x sub e. So it's going to be the price minus the supply function. So we plug in everything we know. So we have 0 to 52.7 again. So it's the same setup. We have 11.11 to start the price minus the supply function. So the supply function's that 0.004x squared. And now we can go ahead and integrate. So it's going to be 11.11x minus 0.004x to the third over 3. One thing to keep in mind too, when you're doing the producer surplus, since you're subtracting off your function, make sure that if it's a function that has multiple terms that you distribute the negative. In this situation, I didn't have to worry about it, but other times, make sure you remember to distribute that negative. So just be aware of that. So maybe putting parentheses, making it 2 steps might be helpful. So then once I integrated here, I'm going to keep my bounds. And then I just plug in. So I have 11.11 times 52.7 minus 0.004 times 52.7 to the third, all over 3. And then from there, we're subtracting off, plugging in 0, which again, you're probably seeing that as that's just going to equal 0 because it's just a number times 0. And then again, another number times 0 to the third. So it's just going to end up being 0. So that just goes away. And then when you type this in, you get a number for that. I ended up with $390.35. Again, it's an estimate. It's rounded because I rounded those equilibrium point values. But this right here is your producer surplus. So this represents the amount of money that producers gained. So consumers spent more money than producers were willing to accept. So this is the gain that the producers got on the situation here. So on the sales. So that's the extra money. So really in this section, it's just taking these two new formulas and you have to do a little bit of work ahead of time to get the equilibrium point, but then once you get that, it's just plugging into these formulas, getting a number, and then interpreting it. So if you have questions, save those for next class, and we'll stop with this section and you can go on to the next one.